Hello everyone. In this lesson, we are going to learn about complex numbers. Complex numbers has a real part and an imaginary part. So here's an example. If I have 2 plus 3i, 2 is the real part and 3i is the imaginary part. So it looks like this. 2 belongs to the set of all real numbers. So we can say real numbers, all real numbers that we've learned so far since the elementary school time. 2 or 1/2, it's also a real number. Pi is a real number. Square root of 2 is also a real number. -1, 0, and so on. These are real numbers. Now 3i belongs to the set of imaginary number. So we're going to write imaginary numbers. And in a set of imaginary numbers, we have square root of -1, which is I. So we could have 3i here, -2i, and 1/2 I, and so on. Anything with I attached to a number is an imaginary number. So together, when we have a real part plus an imaginary part, like 2 plus 3i, together is a complex number. So again, a complex number has a real part, which is 2, and 3i, which is an imaginary number. In this lesson, we'll be focusing on imaginary number. Imaginary number, by definition, is the square root of -1. The square root of -1 is I, and I is an imaginary number. So let's try example number 1. In example number 1, the square root of -49 is the square root of -1 times the square root of 49. And by definition, the square root of -1 is I times the square root of 49 is 7. So we have I times 7, or 7i. In example number 2, we can break it up just like number 1. We have the square root of -1 times the square root of 4. That is the same thing as the square root of -4. And so now we have the square root of -1 is I. Square root of 4 is 2. So we have 2 times I, and we can write it as 2i. In example number 3, we have the square root of -1 times the square root of 45. Now we can break it up further. The square root of -1 is I. Square root of 45 is 9 times 5. And we can do square root of 9 times square root of 5. And we know square root of 9 is 3. So we can say 3 times I times the square root of 5. And that is our final answer. In example number 4, I have -2 times square root of -1 times the square root of 100. And I get -2 times the square root of -1 is I, times square root of 100 is 10. So now I take -2 times 10, which is -20i. In example number 6, I have 5 times the square root of -1 times the square root of 75. And that is 5 times the square root of -1 is I, times the square root of 75, and it can be broken into 2 square root of 25 times the square root of 3, because 3 times 25 is 75. So I could have square root of 25, which is just 5. So I can write 5 times I times 5, because square root of 25 is 5, times square root of 3. So now I multiply the real part together. 5 times 5, that is 25i times root 3. And that is my final answer. In example number 7 and 8, we need to find values of x and y that satisfy the condition. So we must equate the real part together. So 44 equals negative 1 4x, and negative 1/2 yi equals negative 7i, because the real parts are equal to each other and the imaginary parts are equal to each other. So we're going to write it like this. 44 equals negative 1 4x, and the imaginary parts, negative 1/2 yi equals negative 7i. Now we can solve for x. In order to solve for x, we multiply both sides by the reciprocal of negative 1 4. So I can multiply the right by negative 4 over 1 and the left by negative 4 over 1, because the negative and a negative makes a plus, and 4 divided by 4 is just 1. So I have just x equals negative 176, and that is the value of x. To get the value for y, I can divide both sides by I, because both sides has I, so I can divide by I to cancel the I. So now I have negative 1/2 y equals negative 7. And in order to isolate y by itself, I'm solving for y, so I can multiply both sides by the reciprocal, which is negative 2 over 1. Negative 2 over 1 multiplied to the right-hand side. Now I can cancel the 2 with the denominator 2, and a negative times a negative is a positive. So y equals negative 7 times negative 2 is 14, and y equals 14. Now I'd like you to try number 5 and number 7. Good luck on your homework, and I will see you in the next video.